Good morning everyone. My name is Sanjeev Kumar. Here in Perfect Academy, I am senior maths faculty. So for today's topic, we have integration. This integration chapter is very important for any exam. Either it is IIT-JEE or board exam, anything. The maximum part of it will contain the integration part. It is the basic of the integral calculus. Based on this, we have so many things. Like we have differential equation, application of integration, we have area under curves. So this is the basic of all the integral calculus. So today we will see that. Before starting integration, I hope the students would know the differentiation, because after differentiation chapter only we can study the integration. So I am just writing the differentiation of some functions, and we will see simultaneously what is integration. We know the integration of it, we know that the differentiation of e to the power x with respect to x is e to the power x. Hence, the integration is the reverse process of differentiation. So here only we can write the integration of e to the power x with respect to x will be e to the power x. After integrating, we give one integral constant, because the differentiation of this constant will be 0 only. Likewise, we can see differentiation of e to the power x plus any constant c with respect to x as e to the power x only. So we can write e to the power x plus some constant integration with respect to x as e to the power x plus some integral constant. That is the thing. Now we will see more differentiation and more integration on it. We know the differentiation of x to the power n plus 1 over n plus 1 plus some any constant with respect to x. If we differentiate this function, then what will happen? The standard formula will be used, and we can write n into x to the power n plus 1 minus 1 over n plus 1. This and this will get cancelled, and we will get x to the power n. So the differentiation of this function is x to the power n. So we say x to the power n integration with respect to x as x to the power n plus 1 over n plus 1 plus some integral constant. Here obviously the n should not be equals to minus 1, otherwise this denominator will be undefined. So to exclude this, we have one more thing, that is the differentiation of log x with respect to x. We have 1 by x. So we say 1 by x integration with respect to x as ln x. We give here modulus sign because for negative x the log is not real, that's why. Now based on this, we can see some fundamental questions based on integration. Let's see some questions. Suppose we have to integrate this function. The question is to integrate this function root x dx. In the whole integration, what we will do, we will try to put our function in the standard form, and after that we will apply the formula to integrate this function. In the whole integration we will be doing like that only. See, this can be written integration of I will write here the standard formula which I will be using. Integration x raised n with respect to x as x raised n plus 1 over n plus 1 plus c. Based on this, we will see so many questions. For example, here, now we have to integrate this function. This root x we know can be written as x raised half with respect to x. Now this and this is there in standard form where n equals to half here. So we can integrate like x raised n plus 1 divided by half plus 1 plus 1 integral constant. So after simplifying, we will get 2 by 3 x raised 3 by 2 plus integral constant. So this function is the integration of this. So if we differentiate this, we should get this root x. Let's check that. Let's find the differentiation of 2 by 3 x raised 2 by 3 plus c with respect to x. So if we differentiate this, so this is a constant, 2 by 3 is a constant, we can write like that, into x raised n, differentiation is n into x raised n minus 1, and this is a constant, so that differentiation will be 0. Now this 2 cancel, 3 cancel, x raised half. So we are getting this function. So we are true. So after integration, we should check whether we are getting this differentiation or not. Initial stage, later we will not see. Let's see next question. Suppose we have to integrate this function. Integration of root x plus 1 by root x whole square dx. If we see, this is again not in the standard form which we can use. So first we will try to bring it in the standard form using some algebraic rule or trigonometrical function, whatever it is. So this is here the algebra you can use, a plus b whole square. Let's apply the formula. The formula for a plus b whole square we know. A plus b whole square equals to a square plus b square plus 2ab. Let's use it here. So this can be written root x whole square, that is x only, plus 1 by root x whole square, that is 1 by x only, plus 2 into root x into 1 by root x, that will get cancelled and we will get 2 only. So this integration. Now this we can write like that. This is there in the standard form, x raised n where n equals to 1. Apply here. So we can write x raised n plus 1 over n plus 1 plus, just I showed that the differentiation of log x, with respect to x is 1 by x. So we can write the integration of 1 by x with respect to x as log x. This I have proved earlier. Now this we can apply, so we can write ln mod x plus 2 can be written 2 into x raised 0 dx. So here I am writing x square by 2 plus log mod x plus 2 into, now this is again there in the standard form, we can apply here. So we can write x raised 0 plus 1 over 0 plus 1 plus 1 integral constant. So the final integration will be x square plus 2 plus ln mod x plus 2x plus c. So this is the final integration. Let's see next question based on it. Suppose we have to integrate this function. Integration x raised 3 by 2 plus e raised x minus 1 by x dx. Suppose we have to integrate this function. Then what we can write here, this is there in the standard form. Let's write x raised 3 by 2 plus 1 over 3 by 2 plus 1. The integration of e raised x is e raised x only, e raised x minus 1 by x integration log mod x plus c. So after simplifying, we will get 2 by 5 x raised 5 by 2 plus e raised x minus ln mod x plus c. So this is the final integration of this function. Let's see next question. Integration of sin x plus cos x dx. We know the differentiation of sin x is cos x and the differentiation of cos x is minus sin x. Okay? So integration of sin x will be minus cos x, and sin x differentiation cos x, so cos x integration sin x plus sin x plus 1 integral constant. That completes the integration of this function. Let's see next question. It's a good question often asked in the exam. How to integrate this function tan square x? So what we can do here, we know the differentiation of tan x is sec square x. So sec square x integration will be tan x. Here we know from the trigonometry that this relation sec square x equals 1 plus tan square x. So the value of tan square x we can write sec square x minus 1 we can use here. So this can be written sec square x minus 1 dx. Now we know the integration of this, we know the integration of this. So just separate it, sec square x integration tan x minus 1 integration is x plus c. So this completes its integration. Let's see next question.